Hello, everyone. Welcome to the second webinar in our Mobile Mapping Mondays series. Simplicity in post-processing, get a jump start on becoming a pro. Last week, Jason covered the basics of mobile mapping and rapid data acquisition. Today, he's going to go a little bit more in depth. I'm Christine Grail, Content Marketing Manager for Leica Geosystems and the moderator for today's session. Our presenter today is Jason Ellis. Jason has over 20 years of surveying experience and more than 10 years working with laser scanning. A creative thinker and technology advocate, Jason has spent much of his career in leadership roles, including serving as technology director for the Klingers Group and business development manager for TrueScan 3D. In his current role as mobile mapping application engineer for Leica Geosystems, a Hexagon company, Jason focuses on helping companies successfully implement mobile mapping and grow their business. Also on the line with us today is Josh Rayburn, Mobile Mapping and UAV Manager for Leica Geosystems, who will be answering your questions behind the scenes in today's session. We do encourage you to ask questions during the webinar. You can simply type your questions into the questions box, which you should see on your screen. Jason will address as many of these questions as possible after his presentation today. If we are unable to answer all of the questions in our live session, someone will reach out to you after the webinar by email. We are going to go ahead and get started today with a couple of quick polls. If you were on the line with us last week, you might have answered these already, but for those who are new with us today, just joining us for the session, we would like to get an understanding of where you're at with laser scanning. If you could go ahead and answer that question for us quickly, please. It looks like a lot of the folks on the line with us today have experience, but they're still learning, so I'm sure that you will get a lot out of our session today. I'm going to go ahead and close this poll out and share the results. And then we just have one more, and that is, oops. How would you describe your interest in mobile mapping? Go ahead and take a moment to answer that for us. Looks like it really runs the gamut with regard to where our audience is. Everyone is different places, and that's good. I think you'll learn a lot from what Jason has with us. And so with that, I am going to go ahead and turn it over to Jason.
Thanks, Christine. And thank you everybody for taking the time to join us today on this session. So last week we talked about some basic considerations for ensuring success in the field. We talked about mission planning and safety and everything related to making sure that when you go out into the field, you're setting yourself up for the best chance of success. Today, we're going to talk about collecting that data on a Pegasus mobile solution. We're going to see what that looks like. So I've got a video of a collection that I did that I'll explain the different steps of the collection process on a Pegasus system. And then after that, we're going to take a look at post-processing the data in Pegasus Manager and getting to deliverables. And on the tail end of everything, I'll switch over to Pegasus Manager so that you can actually see the results of the data that's collected in the video that I'm going to share with you. So with that, we're going to start by talking about collecting data in the MDA, or the Mobile Data Acquisition Interface. So the MDA is for both the vehicle base and the wearable Pegasus solutions. The interfaces are virtually the same. There's a couple differences because of the amount of cameras and LiDAR sensors between the two systems, but it's virtually the same experience. It's very intuitive for a very simple field operation. It allows you to import mission planning layers. These are the things we were talking about last week. So if you've got shape files or TIFF images or project limits or control placement, whatever it is you want your guys to or gals to have a look at in real time while you're doing your field collection, you can bring that information in and you can see your breadcrumb against that information in real time. The MDA runs on the Pegasus itself. So you're connecting to this platform via remote desktop, either through a tablet or a laptop. It allows for various configuration scenarios depending on your project needs. So you can modify your LiDAR density, your image spacing, things of that nature. And some of this can be done in real time. And again, it's universal between our Pegasus solution. So if you're working with the vehicle-based solution and a wearable solution, the user experience in the field is virtually the same. So it's very easy to move back and forth between these two solutions. So with that, I'm going to show you the video of a collection. So we're going to start the Pegasus MDA, which is the mobile data acquisition software. And on startup, we're going to get a splash screen like this. And basically what's happening here is the MDA is starting up and it's connecting to the cameras and the LiDAR and the light sensor and anything else we might have attached to the Pegasus. So this typically takes a minute or so to go through this boot up process. So I'm going to go ahead and grab the slider here and move forward. Okay. So this is the, when we hit activate in the MDA, we're going to get a window that gives us an opportunity to name our mission. And we can also create a map file here as well. Basically what a map file does is keeps track of where you've collected your data, and it shows you a breadcrumb of the collection in real time. And if you want, you can overlay things like TIFF images or shape files in the map window, which is here, while you're doing your collection. So here I'm just naming the file, and I would create a new map project, and I always give the map project the same name as my mission. And then as soon as we create the map file, we can hit activate. As soon as we hit activate, what we're doing is we're opening the span, which is the brains of the navigation collection. So it's simultaneous positioning and navigation, and we can think of it as a card that's plugged into the Pegasus PC that handles all of the navigation information from the GNSS and the IMU. So I've paused the video, and right here on startup, we can see that we've opened a new span file, and it is a .gps file. So all of our GPS observations from our satellites and all of our IMU information is going to be stored here in this file. Here we're showing that above the horizon there are 19 satellites, and this is how many we are tracking from each constellation. So it's GPS, GLONASS, and Beidou. We can see that the INS, or the Inertial Navigation System, is aligning. So it hasn't resolved itself yet, but this is something that we will do during this initialization. So with initialization, basically we're going to do a 5-minute static observation. Then we're going to do a drive, up to a 10-minute drive, to get the GNSS and the IMU to agree with one another on position and heading. So I'll go ahead and unpause the video here. While we're doing our static observation, and you can see that at this part in the video, it's been going on for about just over 30 seconds. While we're waiting our 5 minutes, we'll go ahead and get the cameras lined out, and you can see that I'm adjusting the exposure so that I have the right amount of lighting in my images, and I had also set the white balance just a few moments ago. And I'm also going to specify the frame distance in our collection. So I get to decide, do I want to have all the cameras trigger at 3 meters or 5 meters or up to 10 meters? And again, it's something that you can control in real time as you're doing your collection. So I'm going to go ahead and grab the slider here and move forward in time a little bit until we get to that 5-minute mark in our static observation. And as soon as we get to that 5-minute mark in the static observation, we're going to start driving. And driving is the dynamic portion of our initialization. And what we're trying to do is get this status message here, this INS aligned OK. We want that to switch over to INS good. And when it reads INS good, it's an indicator that the GNSS and the IMU have a good agreement on position and heading. And we're just going to drive normally, so we don't have to do anything radical like driving in loops or figure eights or anything like that. We're just going to drive our project, and what I like to do during a collection at this point in time is just look for any kind of maybe construction or any type of obstacles, anything that we think might require special attention during our collection. So I'll go ahead and move the video forward a little bit. And after a few minutes, we'll see that the INS aligned OK message switches over to INS good. There we go. So as soon as it switches over to INS good, we should be fine for our dynamic portion of the initialization. We just need to find a safe place to pull over so that we're not obstructing traffic or anything like that. Find a safe place to pull over, and then we're going to hit start record. And basically what start record does is it gets the scanner up to speed. So depending on whatever speed we decided to collect this data at, as far as the scanner goes, it could be 100 revolutions per second, 150 revolutions per second, or up to 200 revolutions per second. This is when the scanner is physically starting up, and we can see those revolutions per second right there in the scanner window. And once it gets up to speed, it's going to build a buffer or a cache for it to log data. And that cache builds up to about 120 meg. It only takes a few seconds to build that cache up, but you can see here that the file size is building up. Once it builds up to 120 meg, we'll be able to see in this window a real-time profile of the LiDAR data. There's our real-time profile. Now we can start driving. So I'll go ahead and move the slider forward here in time a little bit. Right now we're collecting for track A. And at some point in this collection we hit stop record, which would close track A. And then we hit start record. There we go. So here we've stopped recording for track A. And then we start recording for track B. So this is how we split our tracks up. Tracks, flight lines. You think of it as strips of data, strips of LiDAR data with images associated with it. Okay, so I'm going to go ahead and move forward here a little bit in the video. You can see our real-time collection progress here in the map window. And again, if we wanted to, we could have shape files and TIFF images overlaid with this as well. And then as we get close to the end of the project, we hit stop recording, and then we hit stop scanning. This turns the scanner off. And then in this particular video, the next step is our static observation. So on the tail end of our mission, just like at the beginning, we want to do a 5-minute static observation, which you can see down here is counting off since we stopped the vehicle. So as we forward through this a little bit, when we get to 5 minutes, we will deactivate the mission. So up here at the top, we deactivate the mission, and this essentially closes the mission, and we're confirming that we want to close the span log, that GPS file that we created at the beginning. Everything's getting shut down. And then once the span log's closed and we can see that our mission has been completed, we can go to the download window, select our mission, and then select to download all of the data from the span as well as from the laser scanner. When we do this, it compiles the entire mission into a single location on the Pegasus, and that can either be an internal hard drive that we would use Windows Explorer to copy and paste to some external drive, or we can have it write directly to our removable hard drives. So once it's finished downloading, we can close the download window and then shut the system down. And that will be the experience that you would have on a simple collection. This was a 2-track collection with the Pegasus 2 Ultimate. Okay, so that was a typical collection with the MDA. And the next step would be to take that data that we just downloaded from the system and move it to Pegasus Manager, where we will process the data. And we're going to do that in automatic processing, the automatic processing module within Pegasus Manager. So Pegasus Manager is modular, so we have different modules for different functions. There's automatic processing for all your post-processing of your raw data. We have an adjustment package. Of course, we have the mission planning package that we discussed, and we've got some other modules as well that we'll be discussing later in this series. But this is the automatic processing module, or we call it AutoP. And this facilitates highly efficient and accurate post-processing of field data. It typically takes less than 5 minutes to set it up and run it. And it's going to result in a full trajectory imagery and LiDAR data set that you can review immediately. And if you wanted to create reports against it, you could do that as well. And its set it and forget it construct extends the intuitive approach of Pegasus Field Collection. So let's take a look at it. This is, let me grab my laser pointer here. So this is Pegasus Manager, and what we're looking at is the automatic processing module. And generally the way this is laid out is we're pointing this to our collection or a mission folder. And once we do that, the software is going to recognize the tracks that we collected in the field. So in the video, we had 2 tracks, and in this example here, I'm showing 2 tracks as well. But we highlight the tracks that we want to process. And then what we have to do is we have to step through a series of functions in this automatic processing module and set it up to batch process. It's going to batch process from top to bottom. And the steps that we have to be concerned with when we first post-process any mission, I call it the essential 8. So it's the first 8 steps here. We have to step through each one of these and make sure the parameters are set up correctly. And the first one that we're looking at is called navigation preparation. Basically what this is Novatel's Inertial Explorer. And Novatel is a Hexagon company, Leica is a Hexagon company, and our development teams for Pegasus and at Novatel work very closely together. And we're using the Inertial Explorer SDK to present these trajectory processing functions to you. So basically what we're doing is we're giving you everything that you need to post-process your trajectory without having to be an Inertial Explorer wizard to get it done. So you can see here we're importing RINEX data from a GPS base station. So we have a base station that was running during our collection, and we're going to use this base station data as corrections to our trajectory. So we're bringing that base station data in, and we're defining the latitude, the longitude, and the ellipsoidal height of that base station. Once we have that set, there are some other options that are revealed from Inertial Explorer, but the one that I typically roll with is this automatically optimize, or optimize automatically. Basically what this is going to do is allow the trajectory to process multiple times, and it's going to use a quality rating on each iteration of the trajectory to determine which version was the best. And it's going to use that version of the trajectory for the rest of the processing of the mission. Basically what we're doing is, rather than you having to function in Inertial Explorer and manually run multiple iterations of a trajectory to see if you could gain ground here or there, this function very quickly does that for you and uses the best result. We can import individual or multiple base stations. Like I said, we are presenting GNSS IMU advanced parameters from Inertial Explorer, and it gives us the opportunity to optimize the trajectory. Okay, once that's done, we move to the next step. So we go to import scanner files, and this is creating an intermediate point cloud format that we can apply some filtering to. It's an SDC format. So this allows us to filter by grid or distance, by intensity, or if we have a road sign project, or where we have artifacts in our LiDAR, potentially we could apply some road sign reflectivity filters here as well. It takes about 5 seconds to come into this window, set a parameter, and move on to the next step, which is JPEG extraction. So what we're doing here is, in the mission, every camera will have its own LP container file. You can think of this as a compression file, like a zip file. And basically what this does is compresses every JPEG into the singular file, and it's at this step where we're going to extract those JPEGs. So when the cameras trigger in the field, we call that an event. So if we had 1,000 events, that means all of our cameras triggered 1,000 times. When we extract the JPEGs, we'll have 1,000 JPEGs, 1,000 per LP container file. Now, you have the option to extract the side cameras or not, and then you have the options to extract the pavement cameras or not. And you also have an opportunity to play with the exposure and some of the other imagery attributes. The next step is time alignment. What we're doing here is we're aligning the times from the trajectory, so the GPS time that's associated with all the positions along our trajectory. We're matching those to the time stamping that's associated with our LiDAR and our imagery. So this shuffles those two times together and gives us a best fit of our LiDAR and imagery and any other sensor data that you might have attached to the Pegasus. It takes all that sensor data and does a time best fit to the trajectory time. And this is the first key relationship between the sensors and the trajectory itself. The next step is import trajectory data. And what we're doing here is we're bringing the trajectory that we processed in the first step up here in navigation preparation, we're bringing it into our mission and projecting it. So you can see here that the parameter is set by default to automatically select the trajectory from NavPrep. So basically, automatic processing is going back to this step, looking at the trajectory that was determined. And by virtue of having this box checked, we're going to have an opportunity to select a coordinate system to project our data to. What that means is our raw data was collected in the field referencing WGS84. But at this step, we are going to have an opportunity to project that data to some known coordinate system, like a state plane coordinate system or a UTM zone, or maybe even a site coordinate system. Excuse me, like a local coordinate system. To do that, we're using Leica Infinity, which installs with Pegasus Manager. So Leica Infinity runs in the background and it serves as a house or a database for all of your defined coordinate systems. The next step is generate image orientation. So what we're doing here is we're using the calibration files for each camera to orient the JPEGs to the trajectory. So back here on time alignment, we kind of dropped everything along the trajectory at a best fit time. Well, now we're using the internal calibrations to actually place everything or to spatially orient everything to the trajectory. So this is the second key relationship between the image sensors and the trajectory. These are the orientation files that are pulled off of the system. Every time you download a mission, all of your orientation files are pulled down with it and embedded in that mission. So every time you process that mission, you're going to have the relevant orientation files that were current during your collection. Generate 3D Point Cloud converts the SDC file that we talked about up here under import scanner files, where we were converting the raw data to the intermediate SDC format. Here we're converting it to a hexagon point cloud or HPC file. This is the point cloud file that you will interact with when you're reviewing your data before you send it out or before you create deliverables or send it to some other production platform. And I'm going to show you that. So at the tail end of this presentation about automatic processing, I'll show you the results of the field collection that we did in that video. It's at this step where we can apply RGB values from the spherical camera to the point cloud. And we can also apply additional filters like a static filter. So if we sat at red light for 2 minutes, we can filter all that point cloud data out so we don't have a gazillion lines of data at one point. We can apply a range filter, and we can also remove alone points, which are just kind of atmospherical artifacts that really don't belong in the scene and were just picked up by the scanner. This alone points filter really gives us an opportunity to clean the data up before we even look at it. And it's here also that we're using the calibration files for the scanner to orient everything along the trajectory. And then finally, we get to create peg tracks. And what peg tracks is a line shape file that shows you where you were collecting LiDAR and images. So it's not going to show you the initialization 5-minute static and the dynamic that we did after that when we were getting the IMU and the GNSS to align. Those parts of the trajectory are omitted from peg tracks. Peg tracks is created for you to understand what your coverage was during your actual LiDAR and imagery collection. And again, that's collected in the shape of in the form of a shapefile. And you'll see that here in just a moment. Now, We do have the option to batch process additional deliverables and additional functions right out of the gate. So from raw data, we can do the essential 8 like I just walked you through, but we can also start to stack up these other functions like point cloud filtering that includes smoothing and decimation. We can blur people and vehicles. So if we wanted to, if we had a collection that was very sensitive to privacy, we have the opportunity right away to blur the raw data or blur the people and the vehicles from the imagery in the raw data itself. We can deliver to these other formats as well. So topo.las, recap E57, PTX, Jetstream, and of course a Pegasus web viewer. All of these things can be stacked up to run as a batch. So once you check it, it starts at the top of this list and starts to work its way down. Now, if we're doing design work, it's most likely that we are going to go to some sort of an adjustment against survey control. So it may not make sense to create these things right away, but we do have an opportunity to do that if our project allows for it. Okay. And then once we hit process, we are presented with the coordinate system selection window, and this is where we're drawing from Leica Infinity. And in this particular example, you can see that I'm going to project my data to North Carolina NAD 83, and we have the Geoid 12B attached to that coordinate system. So we do get an opportunity to project that data to any coordinate system that makes sense for us. So with automatic processing, field collection time to processing with the vehicle-based system is typically 1-to-1. A 30-minute collection will demand about a 30-minute post-processing. Typical setup for post-processing is less than 5 minutes. So it normally takes me 3 to 4 times longer to talk about it than it does to actually do it. Processing can be interrupted and resumed at any time. So if you're going through your list and you see that maybe you fat fingered one of the options or some parameter you forgot to check, you can interrupt the process and go back, fix your parameters and hit resume, and it's going to pick up where you left off. And other tasks can be completed on the workstation while post-processing is running. It's not a resource hog, so you can focus on other things while Pegasus Manager is doing the heavy lifting for you. Okay, so I'm going to escape out of this, and I want to show you the results of that collection. So this is the collection that we saw in the video. This was 2 passes around several blocks of downtown Peoria, Illinois, and you can see the blue line here. These are our peg tracks, right? So that's showing the limits of the collection where I was actually collecting LiDAR and data. And what you're seeing here is the result of the 360 camera. So this is just one position from the 360 camera. And then if I want, I can go ahead and advance the camera along the track. I have the opportunity to turn that line off if I don't want to see it in my images. I can turn and look around this position here. I can turn off the spherical images and show side cameras if I choose to do that. And then over here, we have the LiDAR data. I'll show you this real quick. So currently, this is an RGB format of the LiDAR. If I zoom out, I give you a feel of the extent of the collection. We can change the view of the LiDAR. We have an intensity by hue. There's a height ramp that we can look at. We can look at it in grayscale. Pretty much anything that you would expect to be able to do with the LiDAR, you can accomplish here. But these are the results of that video that that you saw at the beginning of this presentation. In fact, just to kind of hit on the virtue of collecting and post-processing data, this was post-processed in the field. So, you know, we had traveled to this location for a very specific need, and you know, there were flights that needed to be caught and all of that. So we collected this data, and as soon as we were done with the collection that you saw in the video, we pulled over to the side of the road and stacked everything up in Pegasus Manager, and we processed the data and reviewed everything on site before we packed up the system and headed out. Okay, questions?
Thank you, Jason. We do have a few questions that have come in during your presentation. One question is about the data set that you're showing, and that is, how accurate is each point in the point cloud as far as onboard GPS? And a related question, can I get northing and easting and elevation accurate enough in terms of survey grade?
Yeah, those are both great questions. So the first one is, you know, how accurate is this data? I think the question was in relation to GPS. Is that?
As far as the
correct?
onboard GPS, yes.
Yeah. So I'm gonna actually let me turn my camera on here too. There we go. Get my boom mic out of the way.
Excellent. Thank you.
Yeah, no problem. So when we're looking at, you know, this isn't raw data because we've processed it, but it's unadjusted data. So this unadjusted data has whatever GPS error that we would be experiencing during this collection. So what time of day did we do the collection? What was the visibility to the satellite constellation? What were the physical obstructions to the system while we were doing the collection? These things all play into our GPS accuracies, just like they do if you're doing static GPS in a downtown area, right? You have to plan for best time of day and what type of obstructions are you dealing with. Our trajectory inherits that that error as well, because we're using the same exact technology. It's GNSS. So we have to mitigate that if our project dictates that we have to mitigate it. What I mean by that is, if we're doing inventory for manhole locations or light pole inventory, and we need to be within a foot, then this data is good to go. But this data is probably XYZ, or our 3D accuracy is probably within 2 or 3 centimeters of the truth, so to speak. Now, if we're doing design work, 2 to 3 centimeters isn't going to cut it, right? So we have to lay out some targets ahead of time. So what we would do is we would come out to this site, we would paint some targets down on the roadway, and we would shoot them in and make an adjustment to that control network and use that control in the adjustment module of Pegasus Manager, which we'll get into next week. We would use that control to fix this data closer to the truth. And it's at that point where we typically see sub-centimeter accuracies. I often see accuracies to control to about 5 mils. So to answer the first question, you're looking probably at this data, you're looking at 2 to 3 centimeters unadjusted, and then post-adjustment sub-centimeter is typical. Sub-centimeter is typical. And what was the second question, Christine?
The second related question was, can I get northing and easting and elevation accuracy high enough for survey grade?
Oh, yeah, I think I answered that with my response.
Exactly.
Yep.
Yep. Yep. And another related question to that is, if you were to go back to the site and shoot city monuments, can you then overlay that data and also be within centimeters?
Yeah, absolutely. Yep. Yeah. So one of the things I talked a little bit about reporting. So, when we process this data, the data that we're looking at, and you still see that on the screen, right? I'm still sharing that.
Yes.
Okay. Um, when we process this data, if we wanted to, we could generate a report against control right now. So if we had monument data or control point data, we could generate a report against those monuments or control points against this data before we make any adjustments to it. So, and I've seen collections. There's a few that I've done out west where the constellations are just, the GPS geometry is fantastic. And on post-processed data, we're hitting design quality accuracies before having to do any kind of adjustment. And that's fantastic. I don't plan on any collection to get there right away, but when it happens, it sure is nice. But yeah, you could absolutely bring in some monumentation into this software and create a report to show you how close your results are, your raw unadjusted results are before any kind of adjustment considerations.
Okay, excellent. We have someone else who wanted to know, can you tell us how we can classify the point cloud?
Yeah, we're going to talk a little bit more about classification in the coming weeks, so I would encourage you to sign up. Obviously, you're signed up and you've joined us today, but I would encourage you to join us in the next couple sessions to learn more about that.
Excellent. Here's a great question. Are the point clouds visible in Pegasus Manager while working in a remote desktop situation?
Yes, you can remote desktop into a workstation, and 90% of the time it works great, but all remote desktop software and all business networks are not created equal. So I have seen a few cases where, for whatever reason, the workstation or the remote server in somebody's office isn't able to visually render to the remote user what's happening on the screen wherever that remote server is sitting. So yeah, generally speaking, yes, you can remote into a desktop and manipulate this data, but all network considerations come into play. What's your connection? How is your network constructed? Is there a heavy IT hand on the workstation that you're remoting into? All these things come into play.
It's a great question, especially as a lot of people are trying to work remotely these days.
Right.
Yeah, with regard to that loop that you showed, if you were to put ground control targets to tighten the accuracy, how many would you lay out on that loop?
I typically recommend, on this loop here, on this loop, I would probably lay out 4 to a half a dozen, probably one on each corner intersection there, and then maybe one in the middle. So one, and then one in the middle.
We have someone else who wanted to know. Yep,
I'm sorry.
go ahead.
Yeah, typically every 500 to 1,000 feet. It's kind of a loose rule of thumb. And then, depending on the site conditions, you get a little bit more strategic on how you're going to place them.
Okay, excellent. Someone else wants to know, can information be extracted from Pegasus Manager, such as roads, poles, houses, etc., or is it just for viewing the point cloud?
Yeah, so what we're looking at now is just a view-only module, but we do have a feature extraction module called Map Factory that is that allows you to extract things like signage and poles and things of that nature. And in the coming weeks, particularly in our final session, we're going to have some exciting things to talk about when it comes to feature extraction.
Excellent. Yeah, I hope everyone can join us live for that session.
Yep.
Is Pegasus Manager software included with the Pegasus solution?
Yeah, so if you were to pursue a Pegasus solution and get a quote from your local representative, that would include, all your hardware, your software, your training, everything would be included in that number. So yeah, everything that you would need to post-process and adjust, to do planning, and then optionally, if feature extraction was part of your need, all that stuff will be included in the price of the unit.
Excellent. And what about for someone who wants to pull in multiple data sets? Maybe they want to combine mobile mapping with static terrestrial laser scanning or some other type of data. Can you do that within Pegasus Manager?
Pegasus Manager does allow you to bring LAS data sets for viewing, but if you want to work with data sets from like one of our P series scanners or RTC, or even from a third party in E57 or LAS or something like that, Cyclone's really the way to go with that. Cyclone allows for a direct import of the Pegasus data. So, Pegasus Manager is used for post-processing, visualizing, adjusting, tweaking, creating reports on your accuracy, and exporting to other formats. But it's really geared for manipulating Pegasus data. But Cyclone has a direct import of the Pegasus projects. And it even allows you to create virtual setups along your trajectory that can serve as scan worlds so that you can generate true views and things of that nature. All the normals are included in it as well. So if you want to do automatic, anything that you would do with data in Cyclone, you can do with Pegasus data, as well as data from third party or other platforms.
Okay, what about the meshing of data? Does that happen within Pegasus or within Cyclone? And is there a set procedure for that when we're working with someone?
Yeah, so I'll talk out of both sides of my mouth on this one. So Cyclone certainly has meshing tools and surfacing tools and things of that nature, but we're going to have some exciting things to talk about here in the next couple weeks as well. So you want to make sure you stay tuned to this series so that you can get a full picture of what your options will be when it comes to your production needs.
Excellent. What about, we've talked a little bit about the backpack last session and this one. Is there any difference between the software used? It's still Pegasus Manager, but what about ProScan? When we get into ProScan, is there much difference between that software and Pegasus Manager when it comes to the backpack and mobile system?
Yes. So Pegasus and the vehicle, everything's done in the platform that I've shown you here. ProScan has its own standalone thing, and its interface it's kind of set up the same way where you can run it in the field or you can run it on your workstation. And it's batch, I don't want to say batch driven because ours is very, it's very linear. You start at the top, you set parameters as you go down through Pegasus Manager, and then you let it rip. ProScan kind of works the same way, but you're plugging in a couple different files that you pull off the system, and then you hit process and let it run. So to get to unadjusted results, it's kind of the same philosophy, but it's a different platform, it's a different interface.
So it really depends on what you're running and what the needs are that you have.
Right. Yep.
And you also mentioned Leica Infinity briefly. Would you be able to tell us what that is used for primarily?
Well, I can talk a little bit about it. So Infinity encapsulates a lot of different solutions. So you can use it for our UAV mobile solution. So you can bring the imagery from our UAV into it and generate surfaces and things of that nature. You can adjust control networks. You can adjust survey data. it does a ton of things when it comes to the overall Leica family of products. But in the context of mobile mapping, we use it purely as a database for known coordinate systems. So you would go into Infinity and you would define, like I live in Ohio, so I would define my Ohio state plane, north and south. Maybe I would put my UTM zone in there. And then of course, if I'm working with anybody that's working on a local coordinate system for a project site or something like that, I would define that coordinate system in Infinity. And then every time I post-process Pegasus data, it goes back to Infinity and gives me that window that allows me to select a coordinate system. So again, in the context of mobile mapping, we're just using it to house our coordinate systems, which is great. It's very effective. It's a very simple way to work with it. But in the broader scheme of things, it's a very robust platform for a lot of different other uses.
So there are a lot of different options, obviously, for someone who's getting into mobile mapping, who's looking to up their game in mobile mapping. What would you say is the key takeaway for someone who wants to know, all right, I'm ready to get started. My next step is to talk to someone, obviously, and get a better understanding of where I need to go. How would you get them started?
Well, first, I would encourage you to just reach out to me on LinkedIn, and we can exchange information. My email address is jason.ellis@leicaus.com. So if you want to email me, you can do that. Talk a little bit what your needs and interests are, and we can get you plugged in with one of our local representatives as well. Bring them into the conversation, and we can start talking about what is the right fit and exploring some use cases and looking at some data and whatever else interests you. So just
Yeah, I think it's
let's
really
have a
you
direct
walk them
conversation.
through. Yeah, you walk them through every step and make sure that they're comfortable. It's not overwhelming in terms of knowing right off the bat what software you need. There's a lot of different possibilities there.
Right. Yep. And in the context of these web sessions, which is it's a great privilege to be able to speak with everybody here today. But there's a lot going on here, and it might seem a little overwhelming. But um, you know, the one thing that I love about these solutions is how accessible mobile mapping can be, and with the tools that we put in place, once you've gone through it a couple times and you've got it kind of regimented in your mind of what these workflows are, it's pretty straightforward. So it is something that's very accessible. And I know when I used to look at the greats that were doing mobile mapping 10 years ago, I was always kind of enthralled and captivated, like, wow, that's really, it's probably a very complex thing to get into. And there's a lot going on. There's no doubt about it. There's a lot of technology that's rolled into this innovation, but the way that it's constructed and the way that we present it is it's easy to navigate, but it's powerful enough where you can get pretty much any result out of it that you want.
Easy but powerful. Everyone likes
Yep.
that. All right, excellent. Well, thank you, Jason. That does bring us to the end of today's webinar. Why don't you go ahead and show that last slide with your contact information so that
Yep.
everyone who is on the line can grab that before they leave. Please do tune in again next Monday at 2 p.m. Eastern Time as Jason covers the next topic in our series, Mastering the Skill of Fine-Tuning MMS Data. For those of you attending today's session, you won't need to do anything else. Just follow the link that will be provided to you by email the day before the webinar. Just a reminder, as you exit the webinar, please fill out the survey that should pop up on your screen. We do appreciate your time and hope you found this webinar to be a valuable experience. Thank you, everyone.
Thank you.